everybody, if you answer 2 to this question, which seems to be the obvious answer, I'm here to tell you, you would be wrong. And you may just quit watching the video at this point and go, he doesn't know what he's talking about. Because doesn't this look like just a quadratic equation in alpha, beta, and gamma? This is the Greek letters A, B, and C here. You're used to seeing A, B, and C in the U.S. Okay, I guess more, maybe even more universally. But anyway, alpha, beta, gamma are the Greek letters for A, B, and C. And notice we say that alpha, beta, and gamma are real numbers, all right? But you're wrong about this if you think there's just 2 answers, and that's what's been taught over and over and over. There's a slight difference in the way this is stated. There's actually more than 2 answers, and let's take a look at why. Okay? Nobody said anything about alpha not being equal to 0 here. We just said alpha, beta, and gamma were members of the real number. So if alpha is not equal to 0, then of course this expression just becomes this expression, because alpha would be equal to 0 right here. Alpha would be equal to 0. This would go poof, right? And so in the case that alpha is equal to 0, we just get this statement here, beta x plus gamma is equal to 0. And we get x is equal to gamma divided by beta, okay? So this right here would be one possible solution. Now, of course, we have to stipulate that beta is not equal to 0, but if beta was also equal to 0 here, you would have nothing going on, no equation, right? Okay, so one solution in this case. That's why I said possible, okay? One possible solution or root. Okay, now we go to the part where a lot of people, even teachers, don't notice this, but if you look at the standard well-known hackneyed quadratic formula, naturally you have to presume that alpha does not equal to 0, or you would be dividing by 0 in this derivation that comes from completing the square. So as long as beta squared minus 4 alpha gamma, and this may be the first time I've made a gamma in my life by hand. Okay, if this is equal to not equal to 0, then you have 2 solutions. I should call them roots. Okay, 2 solutions, and guess what? Hardest computation of the night. 1 plus 2. This 1 right here plus this 2 right here is 3 possible solutions. Isn't that crazy? 3 possible solutions is the answer. Okay, 3 possible solutions is the answer, folks. And again, so many people just take this for granted, myself included. You go, oh sure, alpha has to be less than 0, but if you state it this way and you just say alpha, beta, and gamma are real numbers, there are indeed 3 solutions, 3 roots. Three possible. Y'all, it's all about the quantifiers. What are you specifying? A lot of people just leave that out and just assume the formula is true because you see it so often. But anyway, there are 3 possible roots to this quadratic equation. Thank you for viewing.